Hello friends, so how are you? So today we are solving this problem, reschedule meetings for maximum free time 2. So we are given an integer event time denoting the duration of an event. You are also given the two integer start time and time, each of length n. And these meetings are non-overlapping, so we don't have to worry about the overlapping of the meetings. So what we have to do is we can reschedule at most one meeting by moving its start time while maintaining the same duration, such that the meetings remain non-overlapping and to maximize the longest continuous period of free times during the event. So we can visualize like this. So we are given the start time and end time of these meetings. See here, for ith meeting we have the start time. Let's say for this meeting start time is given in this one and the end time is given here as 2, and same for all the meetings. And also we are given the event time, that where this is all the events are ends at 11, right? So this is also given to us. Now the thing is, these meetings are overlapping, non-overlapping. Okay, so we have to move at most one of the meetings, and then we have to produce that what would be the maximum free time. So see here, let's say if we are moving this meeting 3 and 5, so where can we move it? Can we move it somewhere here? No, this is of length 1 only. Can we move it somewhere here? Yes, we can move. So because it is starting at 7 and end, so this is the free time. So we can move this meeting to here. And if I move this meeting to here, what would I get? I would get this free time, right? This would be freed now. So starting from the previous meeting end time and the next meeting start time, right? This is now free. We have got this much of free time, right? Starting from 2 to 4, 2 to 6. So it is 4 now. But similarly, we have to check that, hey, we can do only one of them. So it is not guaranteed that only this one would be giving us answer. There could be some more event also which will give better answer. So we have to check for all of them. So we have to bring back whatever we have done here as it is, right? So then we have to check for all of them, and whoever is giving us the maximum time, that should be our answer. Now here could be the two possibilities. One is like we did this M2, right? We remove M2 and we set it here in this space. But there could be a scenario when we don't have such a space. Let's say if this was only one length, then we don't have the we cannot move it. So, and one more scenario could be like this, that this is the meeting M, and there is no possibility of moving on left side or right side. So whatever space we have to only utilize this space only, this free space, because we don't have to move. So only thing is we can move it into the one of the adjacent, one of the side, and this much of the space would be available for us, right? So that is the another scenario. So only these two scenarios we have to handle. Now next thing is when we are traversing through these meeting array, right? Either from start time or end time, at that time we have to have this information that can we move it somewhere for a meeting. Is it possible to move it left side or right side, not in adjacent way? Like in this case we moved M1 from M2 onwards or M1 left side onwards. We cannot move into adjacent side, otherwise there is no benefit. So what we have to do is we can create a Boolean array, and that Boolean arrays would be having our information that okay, this particular meeting can be moved to anyone, left or right. If any one of them is true, then it would be having a value true. So let's create that Boolean array. Observe, this is our Boolean array. Okay, and this array is of same size like start time or end time, whatever number of the meetings are there. So let's start for M1. So can we move M1 somewhere? On the left side there is no adjacent meeting, right? So there is no this is just an adjacent area where we cannot move. But can we move it somewhere right side out of this M2, on the right side of whoever is the right side meeting, and right of that we are saying. So can we move it somewhere? So I think we can move. Where we can move? We can put it here. 5 to 6 is one length, or also we can put it here. 7 to 9, this is 2 lengths, so we can move it. So what happens? This would be true. Now we will come into this M2. Can we move it? Yes, we can move it here on the right side. Can we move it left side? No, left side we cannot move, but on right side we can move. So if any one of them we can move, then we have to make it true. So this guy also would be becoming true. Now we're coming to the meeting 3, meeting 2, M2. Can we move it? Yeah, we can move it on the left side. We can set it here. So this also would become true, right? Now we are coming to this guy. So right side there is no adjacent meeting, so we don't have any option. But on left side, can we move? This is of 2 length. This is adjacent place, so we cannot move it here. We don't get anything here. Can we move it here? No, 5 to 6. This is of only 1 length. We need to have 2 length, right? So can we move it here? No, this is also of 1 length. This is also of 1 length. So we cannot move it anywhere, neither right nor left. So we can make it this also true. Oh, sorry, false. This should be false because we are not getting at all anywhere movement. So this would be false. Now what will happen is we will use this in one pass. We can create this Boolean array, and when we will traversing for all the meetings of the removal, then we would be definitely use this array, and we can immediately know that can we move it or not. So let's do a dry run for this example. So see here, what we are doing is, let's say we are starting with the M0. So if in the M0, when we are coming here, M0 I equal to, it would be 0, right? So at I equal to 0, we will check in the Boolean array that, hey, is this true or false? So it is true. So if it is true, we can remove it, and what we will get, we would have left side. So this would be on the right side, we have this 3, right? The start time of M2. On left side, we are starting with this left equal to 0. So this would be 3 minus 0. So what would be the value? This would be 3, 4 now, if we remove M0. Now we will check again that, okay, let's say if we remove this M1, then what will happen? So if we remove M1, first of all, we will check that, hey, is it possible to make it true? Yes, it is possible to make it moved. So if we remove these things, what we will get? We will get 2 to 6, right? Starting from 2 and ending at 6, we will get this space. So what would be the value? 6 minus 2. We will get a free space of 4, right? And already we got 3. So 4 is greater, right? So we will remove this 3 and we will get 4 answer till M1, right? Now we will try to remove this M2. We will check in Boolean array that, hey, can we move it? Yes, we can move. So if we can move, we will look for the left side meeting start time and the right side meeting end time. So it would be 9 minus 5, which is 4. So 4 again, so 4 is already max, and this value, so one of them would be so far answer. Now we will come to this M3 that, hey, if we remove this M3, this is false, right? So if it is false, then we are coming to this scenario where we cannot move. Only whatever space we have to be happy with that only. So here we are getting only this 2 space, right? 7 to 8 and 8 to 9. Either we can move it here or we can keep it as it is. Only this place is available. So which is 2. But 4 is already greater, right? So answer would be 4. So this is what we have to do. Now I will show you my corresponding code for it. My code here. So first of all, what we are doing is we are getting this time 1, time 2. These are few variables we will understand. And this is our array, Boolean array is there gap. Okay. Now, first of all, what we have to do, we have to construct these Boolean thing, right? So how we will be doing here? We are starting from the, we are using this for loop, right? Because we have the n meetings. So meet from start. So whatever meeting we are encountering, what is the duration of that? The duration of that meeting would be the end time of I and start time of I, right? End time minus start time, you will get the whatever consumed hours by that particular meeting. So we have a meeting from start and meeting from end. What does it mean is, so because we are constructing this Boolean array, right? This Boolean array we are constructing, and we are checking left side as well as right side. So any meeting which is at ith location, right? So what would be from end same location? From end it would be n minus I minus 1, right? If something is third from the start, then n minus third minus 1 would be from the end, because we want to do in the same loop. We want to check whether on the either on the left side or right side is it possible, right? So that is what I am doing here. So ith meeting from start would be, duration would be end time I minus start time I. Similarly, ith meeting from end would be end time minus start time of n minus I minus 1. So we would be having the duration of ith meeting from end and start, you can say. Now what we are doing here, initially we have given time 1 and time 2 equal to 0. So see here, whenever a meeting from start, right, a meeting from start is smaller than time 1, then we are making it true, because if duration of this meeting is smaller from the time 1 which is coming from left side, if duration is smaller than the time 1 from left side, then only we can move it, right? Just like you can see here, when we were here at m2, at m2 here, this is the m2, and on left side here we got this 2 to 3 as a empty slot, right? So if time 1 was this, so which is greater than or equal to, then this 6 7 can be moved here. So same thing we are doing here. So if time 1 either equal to or greater than the duration of meeting, that means we can move it. So we are making it is there gap I equal to true, right? Now similar thing we are doing from the left side gap as well, right? So for left side gap, what we are doing is, you can see here, this left side gap, after checking this thing, we are making the next room. So see here, if I equal to 0, right? So if I equal to 0, at that time we have to have 0, otherwise n time I minus 1. So you can see here, when we are at m1, okay, so from the left side what we are getting the gap, because I equal to 0 at m0, right? So we are taking this 0, right? But if this was the m1, right, so in that case what would be the timing here? In that case it would be the end time of this meeting, left side meeting, which is sitting on I minus 1. So for that reason what we are doing here is left side gap equal to, if I equal to 0, then it would be 0, otherwise it would be the end time of left side meeting, which is I minus 1. So this would be our left side gap. So what we are doing, time 1 equal to, we are keeping the maximum value, because if we keep the maximum value, we can directly say that okay, this meeting could be moved, right, if we having the maximum amount of time which is so far occurred, right? So that is why we are taking the this time 1. And similarly for the end, from the end also we are checking that if meeting from end is smaller than the time 2 which is coming from the right side, okay, if it is greater, then we are making this also true. Okay, now what will happen, we are looking for the right side gap also. Okay, so if I equal to 0, see here, if I equal to 0, then from left side also this guy would be the last one. Here if it is I0, then n minus I minus 1 would be n minus 1, this last one. So what it has on the right side, it doesn't have anything on the right side, right, because this is the last itself. So see here what we are doing, if it is I equal to 0, then end time would be what, it would be the event time minus end time n minus 1, means whatever is on the left side. So in the question it is given the event time 11 here, right? So this is the 11 here, and what would be the end time of the last meeting, left side meeting, this would be the I minus 1, right? This is the 7. So this gap we would be getting once we are coming to this place, right? So same thing we are doing here. You can check here, if I equal to 0, at that time what we are doing, event time minus end time of n minus 1, this gap would be available for us. You can clearly see this is the n minus 1 7, right? So 9, it would be like 11 minus 7. If we remove, the gap would be here. So same thing we are doing from the end. Otherwise if I is not equal to 0, then this would be a simple case. So whoever on the left side meeting and the this difference, start of time n minus I minus end time of n minus I minus 1. You can see here, let's say this was the case here. So if we remove this guy, what would be the difference here, the end time of left side meeting and this is the start time of the right side meeting. Only that difference we are making here. Okay, now here also we are keeping the maximum value, because if we keep the time 1 and time 2 maximum, we can directly say that okay, this max value available, we can move it. Okay, so now finally till here we are fulfilling our this boolean array, that we created here. Now some of you might have the question in the mind that what this n minus I minus 1, why we are doing, because in the left side and right side we have to check every value. So guys, you can observe here when we are coming to we are starting from I equal to 0. So these value interchangeably would be repeated, that if something is third from start, there would be a time then when it would be reaching to the third from end, then again these value would be repeated, right? I and n minus I minus 1. So in this way it would be checked for both side in the single pass only. That is why we are doing. Otherwise we could have done it using the two pass also, starting from I equal to 0 and coming from the n minus 1 also, right? So after filling this this boolean array, we are coming here. Now our thing is we have to now traverse through this event array, right? Maybe start time or end time. So we are starting from here. After filling this we started, right? So same way we are doing here. So see here, we are keeping two things here, left variable and right variable. Okay, so if I equal to 0, in that case we are starting from 0 only. Otherwise it would be the left side end time meeting, correct? For example, if we are starting here, the left side is starting from 0 only. If we were at this meeting 1, at that time what would be, if we remove it, what would be the gap start time? Gap start time would be the whatever is the left side meeting, which is sitting on I minus 1. So end time of I minus 1. Okay, so that would be these two cases we are handling. In case of I equal to 0, the very first, then it would be 0. Otherwise whatever the end time of the left side meeting. And similarly for right side meeting, if I equal to n minus 1, okay, if I is the very last guy, like this M3, if I is the very last guy, in that case what will happen? In that case, so it would be event time, the given in the question, right? 11 in this case, event time minus yeah, so right would be event time, otherwise it would be start time of I plus 1. So in this case it would be event time, or if it is something like this M2, at that time it would be whatever is the I plus 1 and start time of it, basically the right side meeting. Okay, so that would be the right variable. Now we are checking here for that ith thing that, hey, is it possible to move it either left or right? So that information would be true if it is possible. Then what we are doing, we are taking this answer, we are getting the maximum of right minus left, because if we remove this meeting, right minus left would be the value. So we are parking it into our answer variable. But if it is not available, if this is not true, means we cannot move it. At that time what was happening, whatever space we have, so right minus left minus whatever is the duration of that meeting, we are deducting in that way, just like we had this case, right? The M3 case. So in this way what is happening, finally we are parking the highest value into the answer variable. Now once we are coming out of this loop, answer would be having in this variable. So let me execute this code, which I have already submitted. So let me try to submit it. So here what is the time complexity? We are taking in O of n only, and space complexity is also O of n. So now can you guys think of without doing the extra space also? So boolean array, if we remove, can we manage it in without using extra space? So that's, you can try on your own. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.